We're continuing a look at the quadratic formula, but a little bit different. So there's a portion of this, the part under the root is called the discriminant. Gets a special name, and this is really just a logic puzzle. Do you see that different things would happen depending on what happens underneath that root? So for instance, in our last video, we saw that sometimes what's underneath there is 0. So if you wind up with plus or minus the square root of 0, well, that's not going to add anything to the solution. So here's what they're saying down here. If you get a 0 under there, every single time you're going to have one solution. And it's just logic. If you had a 0 under there, you're plus or minusing nothing, so you're just left with like a single answer. Now, if you have a positive number under there, so you've got plus or minus the square root of something under there, well, you're going to have the plus and minus involved, which is then logically going to give you two solutions. Well, the third alternative is that you could get a negative under there, which means, well, we're going to say no real solutions. There's something called imaginary solutions, which I referenced in the last one, but for our course, we're just going to say that's no real solutions because we have a negative square root. So the options here are just totally logical. That's all it is. So if we, this is asking us to just use the discriminant to just tell, not get the answer, but to tell what number of values we could possibly get. So just going through here, they're just doing the discriminant portion of the equation, and they get negative 39. Well, that's really the part under the square root, so there's no real solutions. They're just doing the discriminant portion again. They get 157. Well, that's a positive number under the root, so there are two possible solutions because what's in front of this is plus or minus. They get a negative on this one. Again, just doing the discriminant, they get a negative, so there are no real solutions. This last one they work at, they get a 0. So the square root of 0 is 0. Plus or minus 0 doesn't do anything. So it's again just the logic. So we're just going to get one solution. Okay, so let's go through some of these. So we're going to just do the negative b plus minus square root of b squared minus 4ac. I got to talk my way through the formula. That's the portion that's underneath the root. So we're just doing b squared minus 4ac. And we're going to look at the number that we get as a result, and we're going to be able to tell how many solutions we would have. So I've got minus 192 Okay, now I'm tempted to keep putting the root back on there, but you don't have to, but that's what's happening. I get a negative number. So I have no real solutions because that negative is really under the square root, so no real solutions. So do a couple more. So we're on b here. So I've got b squared minus 4ac. So we're just doing the discriminant. I get 36. So I get 76. Now that's the number under the root. So that's a real number. And so we're going to get two real solutions. Okay. Yeah, this one is going to be. So I'm going to just do C here again, I think. So, or maybe I'll do all these. If there's another one, I'm going to skip that. So we got b squared would be 24 squared minus 4ac. Now I have a feeling these are the same number. I'm sure of it actually. So this is 576, and I bet you that's 576 as well. Yeah, so we are subtracting the same number, so we get 0. Well, we're plus or minusing 0, so that's not going to do anything. We're going to get one solution. Okay, so this is again more plug and chug. I don't know. Let me do D just in case, but I don't know if I'm going to do another one. So negative 2. Oh, hold on. I'm doing the whole thing. I keep always doing that. Negative 2 squared minus 4ac. Okay, now you can probably already see where this is going. This is going to get me a negative. So really, if this is the question, you wouldn't even really need to find what the number is. But you get negative 144. That's underneath the square root. So no real solutions. Hold on, let me see what else is here. I wouldn't mind you working it, but it's going to be the same thing. Hold on, let me step out of this for a second and see what we're doing here. Yeah, I'm going to go ahead and pick it up here with this. So that is just plug and chug on the discriminant. Let's talk about what they're trying to say is let's look finally to see what method we can use. Now this is a little bit of a silly question because they're pretty obvious and the quadratic will always work for you. But so what they're saying here, this is the first thing we learned. We could simply just divide, because there's only a z squared and there's not another z, this would be easy to just use the square root property, where we could just divide the 5 away and square root both sides. Okay, now here on this second one, this is a perfect square trinomial. So we could factor this, which is great. If you don't see that though, the quadratic will work for you. But this is a perfect square on the front and the back. We've got the right middle. So we could have turned this into 2x minus 3 squared in order to solve it. Oh, yeah. I would have written it like this. 2x minus 3, 2x minus 3 equals 0. Set each of those to 0, you get x is 3/2. Now this last one here, we've set it up so we've got it equal to 0. But if you look at this, I don't see any patterns here. Quadratic is the way to go. Okay, so I'm going to start with B here. Do you see this is already set up to just square root both sides? So that's what I would do. Yeah, this one. So these other approaches are good. It is much faster if you can just recognize the other pattern. Again, the quadratic will always work though. But if I see here, I could factor this down to x plus 4, x plus 2, which would be a lot faster than the big quadratic. So that would work there. And then if you set this up here equal to 0. Okay, well, we've got this. This is a mess. I don't see anything we can factor, so or complete the square here. It'd be terrible, so I would use the quadratic. Okay, pause it if you want to try yourself here, but I could divide both sides by 5, so I could use the square root property of that. I bet this factors, but I'm not sure. So you could factor that, I think. This one I would definitely do the quadratic. Those are really nasty numbers. Yeah, this does yeah, this would. So this is 2b plus 1, 2b plus 1, so it'd be easier to just factor that and then solve it. Okay, now there wasn't a lot there, so looking at the methods to use, they're pretty intuitive. Just remember the quadratic will always work for you, but if you see something faster where you can factor it, you should do it. It'll save you a lot of time instead of all the square roots and all of that. And then just remember the discriminant idea is just pure logic. It's just the simple idea that what's underneath there, it logically tells us what's going to happen. If you wind up with something underneath that square root, you're going to get 2 real answers. If the square root, you get a 0 underneath there, then you get just one answer because you don't have the plus or minus. And lastly, if you get a negative under there, you're going to have no real solutions because you can't take the square root of a negative.